Morning Thicketeers. Today we're going to be looking at a thicket-wide plot that was planted in 2008. This is P095, planted at Kabucha Farm, which is managed by Ian Ritchie, and you can see the 50 by 50 meter fence running up there. We've got kind of semi-intact to intact spekboom felt above there. You can see all that light green, that's all spekboom, and we can see that it kind of looks like fairly high rates of success with all the truncheons that were planted in there. That landscape looked very much like the rest of this landscape at the bottom here, and that kind of looks like high rates of success. But interestingly enough, this is one of the plots that only had about 30% survival, and yet we'll get up and have a look at what's going on in there, and we can see why it looks so impressive from afar. And that's because many of those spekboom have now started their sideways creeping, and so they are starting to expand across that slope and stabilize it. So let's get up and have a quick look at it. On our way up to the plot, you can see that these last remnants of the trees that were here are really suffering, especially during this drought. This is a papaya. You can see there's been lots of dieback, and is only really has leaves on the internal branches there. And there are a lot of trees that have fallen over here. There's one over there, there's a whole stack over there, there's another one over there. So once the thicket's been taken back, there's some more dead trees there. Once the thicket's been knocked back, the trees struggle to survive and they die back. Now you can see those trees have also died there, and they've been eroded out. Yeah, so once the main thicket gets taken out, then there's kind of high levels of tree mortality. If you compare the densities of trees up there to what's down here, we can see that we've lost a lot of the trees. And in this thicket-wide plot is an existing clump already, so I don't think that that's a result of the experiment that was run here, but all this short stuff that's in front here is directly from the result of the thicket-wide plot experiment. So just in a quick explanation of the thicket-wide plot experiment, I'm sure most of you are familiar with it, but there were 300 plots that were planted across the Eastern and Western Cape, and each plot had multiple treatments. So they had very large truncheons that were put in, very small truncheons, some had sealant, some were watered, some were created what we called stompies, where you put the truncheon in the ground and the kind of top 10-20 centimeters gets cut off. And one of the things here is that we can't, that it looks like there are a whole stack of different treatments that did work. And what was interesting is that you can see on that side the plants are looking much better, and on this side they're much shorter. And that's because for a few years this fence was down and the animals were getting in from this side, and it was creating like a browsing dent. Browsing was quite heavy on this side and then quite slow to that side, and then all these plants have bounced back once that fence was put back up and repaired. So this is a really steep slope. I'm not sure if you can see just how steep it is in this imagery, and there's a lot of water erosion, and so the water creates gullies, and there's not much that has naturally come back here. You know, the important thing to realize is that this has been fenced off, and we do have some karoo bossies that are looking really bad in the drought. So these are probably pensias, and maybe pensia and cana. It's actually, I can't tell. There's no leaves. They're just sitting there waiting for rain. But there's nothing that's naturally come back here. These have been planted in here. But here's the crucial, amazing thing about these spekboom truncheons. They were planted in here. They growing tall, but now they've started this sideways lateral branching, and they're starting to root. And so if I go and pull this up here, there, Do you see all those roots in there? And this is the kind of landscape level ecosystem engineering that this plant is doing, because it's now trapping silt behind it. If we just look at the lay of the land here, we've got water flowing down this way, and now we've got actually a buildup of silt behind these plants. Looking at the soil above this little clump, just for example, you can see it's very rocky, and the water runs through here and kind of tumbles all this down, and certainly there's a lot of transport that's going down. Oh, that's from a tea bag experiment that we've been conducting out here. We're going to come and collect that, but that's a different story. That's why there's a tea bag in the middle of this landscape. But let's go and have a look inside this clump and see what's going on there. No stones, all just fine silty sand, because that's what's being trapped here. This stuff is trapping it's not looking great in the contrast. Let's go somewhere out a little bit. But this is all been trapped. There are no stones in here. This is all the fine silt material that's been trapped. And I'm getting deeper and deeper. I'm still not getting to that stone layer that was there. It's all silt material. So this is effectively acting as an erosion barrier. This whole thing here. Let's just come around and have a look on this side, because this is even more impressive. So we've gone from a couple of truncheons to, let's get down here. I mean, just look at this mat of speckle. It's almost like a lawn of it, and we can see that it's got red tips, so it's growing. Even though we've been in a extreme drought in this part of the world, we've got there's still evidence of recent growth. Probably the last time it rained, we had a 5 mm event about 6 weeks to 8 weeks ago, and this growth probably happened there. And you can see the rooting going on there. So this is the creeping rooting form. Stuart Hill, 1992, wrote a fantastic paper about this creeping that speckbum does, and that's mostly because what the argument is that goats come in low and clear out the skirt, whereas elephants come and browse from the top and promote the skirt. But this is why this skirt is so crucially important in being an ecosystem engineer. Here's a treatment that seems to have done really superbly well in this particular landscape. There's there must have been a row here and a row there, but those plants didn't do too well. Just remember that those plants were already in the landscape. So this treatment, that treatment didn't do too well. There's another treatment going down there. It seemed to be okay, but this one did really well here. And you can see there's a bunch over there we're going to go have a look at now. This is the aim of speckbum restoration, to get this plant to start growing like this, so we get this sideways lateral growth. But not only that, we also start getting a build-up of leaf litter. See that leaf litter that's starting to build up there, starting to get trapped in there, and after many years, this leaf litter layer gets incredibly thick. I don't know if you can see this, but so this is the natural lie of the slope, and this is definitely a raised, it's starting to become raised because of all the soil that it's been trapping behind here. And you can actually see how it's been trapping the soil, because you can see that these are now buried. So the interesting thing about speckbum is it doesn't grow under the ground and pop up, which is called root suckering. It grows these lateral branches, but the lateral branches can grow down. Let's see, they can grow down and then they can be covered, and then they pop up, they create new individuals. I'm gonna take this one is well stuck in the ground there. So there's the lateral branch that's starting to, that was originally planted. So that was a good kind of 2-3 centimeters down. So this has trapped a good 2-3 centimeters of growth, and then this is starting to create almost a new individual, because that's now buried because of all the soil it's trapped. So yeah, so one can imagine, you know, on these slopes there are very few other plants that can do this. They can grow along on the ground, creeping like this, act as a silt trap, but also act as a water trap. Unfortunately, when we planted these, and the experiments, they were done for scientific purposes, so they were done in lines, up, down. But just imagine what the effect would have been had they been planted in lines and very close to each other, going this way along the slope in a contour. And you can start to see where these two plants obviously I think they must have merged, and then that's automatically starting to create a contour, and it's building up, it's trapping soil. And so planting speckbum in contours will just create these like micro dams and micro erosion control that then gets going. The crucial thing, of course, is to maintain low levels of herbivory while this process is taking place. And after that, you know, this stuff can all be eaten, this top stuff, as long as we maintain the top, as long as we maintain the bottom levels. This top stuff can be sacrificial for game or domestic livestock. One of the things I like about this site is that it's still got an intact patch, or a remnant patch. And let's go and have a look at that, because that kind of gives us an idea of the end point of where we want speckbum restoration to go and what we want happening on these landscapes. Here we've got a Scotia aphra. Remember, we're in a hectic drought. There was a small rainfall event recently, and I think the Scotia has been flushed out with new leaves just from that one rainfall event. And here we go, you can see how big this speckbum is here. Getting in under there. See the size of that. Really big stems leading in there. Let's find a nice spot that doesn't have a patalicia sticking out of it. Yeah, there we go. Let's go have a look inside. Let's go see what's going on underneath here. Quite an environment. Just look at all this leaf litter that's being trapped in here. So it's leaf litter, it's also branches. So let's have a look down there. I'm on a hectic slope here, hey? So just remember, there's not leaf litters heading downhill a little bit, so it's probably trapped much deeper further, but this is on that slope. So let's get down over here. Oopsie. You can see the leaf litter that's happening here, that's accumulating. Richlechmerto, in his PhD, came up with a concept that I think is absolutely fundamental to understanding what speckbum does and what, you know, does in this landscape as part of the thicket. And he talks about open systems and closed systems. And when he's talking about an open system, and when he's talking about these systems, he's talking about what's happening to the nutrients and what's happening to the water. So in an open system, I say some nutrients or some water or land, and then it either gets blown away or washed away. And so an open system has got a flow through of water and nutrients. A closed system, on the other hand, means that there's an accumulation, there's a cycle of accumulation of water and nutrients. And that's what speckboom does. So if you've got any dust landing on here, it gets trapped into that leaf litter. If you've got water flowing down this hill, it gets held up behind this like micro dam, and it gets trapped in there. We also got to remember that speckboom can absorb a huge volume of water if it's been drought stressed, and it can absorb, our current estimates are 3 liters of water per square meter of a single rainfall event, and then it can use that to get going. And also that leaf litter layer largely gets maintained and kept in there. Let's go and see. This is slightly flatter here, so I'm expecting a bit of a better leaf litter layer, and I can actually get into it. There's less putterlick here, so I'm going to see if I can crawl in here or kind of work my way in. Okay, let's clear up this view. Okay, if you don't mind, you just be out the shot for a moment. Here's another piece. Let's be out of. Okay, now we got a good view of what's going on here. Let's see. So that is all this leaf litter that's accumulating here. Look at that. Incredibly rich. Look at the size of that stem. So these stems can increase by 15 to 20% if it's increasing in, that's where your water holding comes from. This is one of the slightly shallower leaf litters that I've seen. You can get much deeper. It's also highly variable underneath the plants, but I mean, this is very much like what you would consider kind of a forest leaf litter layer. Yeah, you'd want this on your garden. This would be great stuff to have in your garden. I found another patch where I think the kind of micro topography has helped in trapping more leaf litter. So remember, it's going to be highly variable underneath the canopy, but let's see what's going on here. Let's just see how, I think this spot should be quite deep. Oh, there's a lot going on there. And I've found, the life in this leaf litter layer is amazing. I've found in the middle of a hot summer's day, cooking above, it's like 35 degrees above, and I'll be underneath this canopy, it'll be much cooler, and I'll find frogs. Like I'll see a frog waddling along through the leaf litter. There's just so much life that happens in this leaf litter because it's a completely different microclimate to what's going on above the canopy. So this is what Richlechmerto talks about in his kind of closed system idea, that this stuff's being trapped here. It's not being washed down the slope. It's staying here. It's decomposing. So any dust input, stays here, accumulates. Any of this leaf litter stays here, accumulates, and starts enriching the soils. Let's have a look at what the canopy looks like. So if you're underneath here, what does it look like? Lovely and lush and cool. I can say that in hot days it's fantastic to escape underneath a dense speckboom canopy to just kind of cool down a bit. One way to tell if you're in degraded thicket or not is a clear indicator. If you find this, so what this is the outer kind of bark of Crassula ovata, and it stays in the landscape for decades after the rest of the thicket has been removed and destroyed. It almost seems like the trees are also kind of eaten up and decomposed, and this stuff doesn't. It's also a fire starter. You can just light a little bit of this and the whole thing goes up. It's like a fire lighter. It's used in this part of the landscape as a firelighter. So if you ever see this kind of this kind of shell. It's from a massive crassula ovata that used to be here. Here's a little bit more of it. There's more there. This is what it can look like. Yeah, you can see where the individual actually was in the ground. Or it's been buried. I'm not quite sure. There's more. So yeah, anytime you see this stuff in the landscape, it sticks around for ages. One of the great indicators that it used to be intact thicket that supported crassulas. I think I spotted a crassula somewhere around here in this intact thicket here. Let's just have a quick look. Oh, there's a piece. There must be a healthy individual somewhere. So this is the crassula. There's one. Here's some growing in down here. So while there's enough moisture, they can survive. There must be a big plant. There's a big plant up there, growing in amongst the spines. Oh, it's actually flowering. Hello, you. Beautiful flowering. So there's a nice big plant. They can get massive. They can get 2 meters tall and have a really thick stem. You can see this, so there was obviously another stem here that died off, but you can also see the way that it regrows is that a small bit falls off and then they kind of hit the ground and then they start rooting. There we go. Here's an example of, come on, focus please. There, yes. Come on, focus. There. And see how and so a new plant can start from that. Although they've got to survive the drought and herbivores. There's some more rooting taking place there. But they need, I see there's quite a lot down here. There's some more rooting. But they need to be in landscapes that there is speckboom, or at least that they aren't on these very arid slopes, because if they're on these arid slopes then they do appear to die and remain in the landscape. So I'm standing in the top corner of this thicket white plot. That's what this landscape looked like before, and this is what this experiment shows us is the potential. And it's weird to think that this isn't even one of the most successful plots. There are plots that show much better. There's that plot at Kudusput that was in an earlier video that I shared, where it's it's wall to wall speckboom that's taller than almost taller than I am. But even this short speckboom that's growing sideways is doing a fantastic job. You can see a small little kind of dam and erosion wall building up there. Anyway, we just need to get the conditions, get all the different range of conditions right to be able to use this to fix and restore much of these landscapes. Let's go and have a look from the top of these 3 rows, or the rows on this side at least, are doing so well. remember that's the intact shrubs that were here already. But all of this is changing this ecosystem from an open ecosystem to a closed system, where we're keeping the soil, keeping the moisture on the slopes, not just having it run down and create gullies and erosion, keeping the nutrients, building that up, and then that creates fast plant growth because we're getting water and nutrients in an arid landscape, and then we should be able to support more animals, whether they be domestic livestock or indigenous herbivores, up to a point. You know, the crucial thing is to be keeping track of the skirt and having your browsing promoting the skirting effect and not trampling it back. But I'm sure it's all very, very doable. Okay, that's all I got for you today. Hope that was enjoyable. Cheers. Bye. Wait a second. Not finished quite yet. Coming outside the thicket wide plot, I came across these two old individuals of speckboom, and you can just see the issue of herbivory and how that changes the growth form. I mean, this poor guy is playing a complete kind of just hanging in there game, and you can see it's been bitten all over, a completely different growth form, just kind of hedged, and it's not doing that skirting, it's not doing this. Okay, this one is to a tiny degree, but effectively it's, and look how thick those stems are. There's barely any like major growth on it, and you know, they're not expanding, they're playing a kind of a herbivore retreat game. And you know, just compare it with what's happening there on the skirt, where the herbivores are largely just kept out by this fence, and that's the difference. So we need to be mindful that the ecosystem engineering properties can only happen in periods where there's low herbivory, and we need to be able to, what those levels of herbivory are, we don't quite know yet. I mean, we still need to figure this out and understand this process, because this definitely is a vegetation that's used to being browsed, and we just need to know what are the sustainable levels so we get that and not this. So lots of research still needs to be conducted on figuring out how to do that, and one just needs to remember that there is lots of intact speckboom up there that doesn't look like this. So as soon as your canopy cover drops below a certain threshold, then these guys really do get hammered, because they're the only things left in the landscape. Whereas up there, it's not so bad, because there's a large diversity of plants to be eaten, and so kind of there's a spread of the herbivory. Anyway, just a last parting thought, things that we need to think about.